Yes, I'll do a quick 3-minute intro. So thank you for joining us today, and then please save your questions to the end and mute yourself. So that way it's more interesting for people on YouTube to catch up with the event. And yes, we started as regular function service developers, but very soon we realized that we can help businesses by working smarter, not by sprinting faster, like in the Scrum terms. So we started defining serverless not just as a tech stack, but as pragmatic mindset for solving business problems. And as engineers, we like to engineers. And unfortunately, way too often we focus on the tech tools, not the things that tech tools let you do. So using the analogy with car mechanics, we too often enjoy pipping our cars more than driving the business forward and taking them places. So that's why we now say the serverless is state of mind and the way to focus on business value. And I know that sounds fluffy. So in simple terms, it's how you triage the problem. So in general, if the platform has it, you're going to use it. If the market has it, you're going to buy it. If you can change the requirements, do it. But if you have to build it, then own it. And we believe that this thinking can be applied to any tech stack, even on-premise. And so this loose definition of serverless allows us to explore various IT topics. And we have nothing scheduled for November and December, but if you go to YouTube, serverlesstoronto.org, you will see like almost 7 years of meetups on all over the place. And I'm sure you're going to enjoy them. So if you have any non-promotional altruistic topic you'd like to share, please DM John and me, and we'll pass you in like November, December. We are free. And last but not the least, I want to thank Mining Publications for being a knowledge sponsor, like 5 years now. And they donate one title at every meetup. So please do the survey to be eligible for the raffle. That survey is going to help us improve the group. It's bit.ly/SLSTO. And those who don't win in the raffle, Mining was generous to give us 45% off code, Toronto24. You can scan this barcode and to get 45% off. But today I just checked, they have Halloween 50% off all books. So save this coupon code for other times. They have really good titles. And then why this session? So Java has historically lagged in serverless adoption, primarily due to the long cold start. So however, this issue is now resolved, so it's time we cover this topic. And we designed this event to benefit all Java developers, regardless what cloud platform you want to migrate your workloads to. So that's why we invited two experts, Vadym, to provide AWS perspective, and then to share insights from Google Cloud. So thank you, gentlemen. And Vadym will kick things off. So I'll stop sharing screen now and take it away. That was less than 2 minutes, 3 minutes.
Yeah, thanks a lot, Daniel and John, for inviting me. It's also my pleasure, to share the stage with Dan. Now you can see my full screen or not? Yeah, probably, yeah. You see the full screen, and I can see you. Yeah, so I just, the topic that I will be presenting, I will probably require something like 25 minutes, and then we can answer the questions. It's more about how performance serverless Java on AWS, basically on Lambda. What I saw, probably that Dan might be talking also about containers and all other stuff, the things that might be applicable. I'm also curious, but I will cover basically only serverless offering Lambda, not EC2s, not servers, not containers, but I can say what technologies might be applicable there. But let's start. Yeah, my name is Vadym. I'm Ukrainian native, but I live since 2000 in Germany, so more than half of my life. And I have these two passions, Java, and I'm one of the co-organizers of Java user group Bonds since 6 years, and I'm also AWS community builder in serverless category, and I just also blog frequently, digging into different aspects, what you can optimize and so on. Basically, probably we all will agree, or at least people working with Java, that Java is a very mature and fast programming language. Generally speaking, the community is awesome. Such events then came recently from DevOps Belgium in this huge cinema. It's fantastic. I was always rejected with my talks, but I know that it's a huge event and there are so many of them. But yes, what Daniel said, the serverless adoption is lacking, and this is the adoption of Java. So if you choose the serverless offering Lambda and choose the programming language Java, then you see this kind of service that have been done 2021 and last year, and we see, yeah, Java is top 3, but the adoption maybe increased from 4% to 10%, so only 10% of written Lambda functions are written with the Java programming language. And this is, of course, doesn't correspond what we see maybe with containers, with enterprise applications. And yeah, there are several reasons. The biggest one is these are so-called call starts or latencies, but there is also a bit of memory footprint, which is at least on AWS can correlate with a bit higher cost, because how Lambda is priced, the memory is one of the criteria. Of course, also execution time and the memory that you select, not exactly that how much memory your function consume. Yeah, it can be less, but you pay for the upfront selected memory. So let's dig into this cold start. You don't need to be a huge expert in AWS, but basically there is some basic application that we can use for benchmark. There is API gateway for receiving the public request. There are a bunch of Lambda functions, simplified application, create products, get products, delete products by ID, and to be completely serverless, the things are stored in the serverless DynamoDB database, NoSQL database. Yeah, we will start benchmarking, giving Lambda function 1 GB of memory. It's always a good starting point. x86 default architecture. If we don't select or don't set the HTTP client, and you need one to talk to DynamoDB because we talk over HTTP, the Apache one will be default, and such application with all dependencies will have 18 megabytes of size. It will be also important. So I did some stress tests, like for 1 hour, putting some load on kind of executing mainly get product by ID function, just hundreds in parallel. Then I paused for 6 minutes so that all kind of environments with Lambda function will be kind of removed, so that we then have cold starts. Not very usual pattern, but just to see. It took 1 hour, and I mainly had 100,000 executions. This is the warm start, and only 100 of them were cold starts. So let's see what we will have without any optimization on AWS Lambda. So the first thing is, if we look into the warm starts, and you will see this warm signal, this basically you see P90, for example, all P's like percentiles. So for P90, that means 90% of the requests will be 7 milliseconds or quicker. Basically, if we now forget this max value, I will explain it. We see warm starts are pretty quick. And this corresponds to the language. Java is a very quick programming language. About the cold starts, there are good news, because I only experience in 0.1% cold starts. Depending on the traffic pattern, it might be up to several percent in your case, but generally cold starts happen not very frequently. But if they happen, then you see the results. So for example, P90 is 3.2 seconds of the cold starts. Yeah, and sometimes the architecture, so you see that's quite significant. And you probably know all these researches that after 1 second, people may jump off from the page and all that stuff. If, for example, login function takes 3.3 seconds, then just you may lose people, you may lose money. But of course, I'm only focusing here on optimizing Lambda function, but the latency is of course the amount that it takes from a request made by the user to the time it takes the response get back to that user. Yeah, and Lambda cold start and even warm start is only part of the game. We will not focus on just basically create and send the HTTP request to API gateway. API gateway needs to process the request, and then in the end, it needs to process the response and give that response to the client. The client needs to process that. So we, at least for API gateway, we don't control it. It's managed service, but just to have an idea, we're only talking about those two lines basically, and basically only cold start, and only this cold start might be more than 3 seconds. So without any optimization, of course, it's too much. Other programming languages like JavaScript, derivatives, Python, they will probably have something around half of the second, maybe 600-700 milliseconds, but not in that dimension. So we will be talking about two options. Mainly, I will cover AWS Snap Start, and will only briefly talk about GraalVM native image, because also then we'll be covering that. It's technology which is universal and can be used also outside of Lambda, like also in containers, but AWS Snapstart especially is the service which currently only works for Lambda and only works for AWS. So it doesn't work for containers and all this stuff. It's only Lambda and only for managed Java currently. Yeah, so you cannot use Snapstart with Python, and also currently it's only available for Java. I blogged a lot about that. You can find me on Dev2. I will only summarize the most important topics. So what is Snapstart? Snapstart is for Java can improve start-time performance, cold starts for latency sensitive applications. So if you have this kind of public facing application, then probably the latency is the factor that needs to be minimized. And Snapstart is fully managed. We will see what does it mean, but basically you decide on per Lambda function. So for example, Lambda function get product by ID, you decide whether you would like to have it or not, and it's basically checkpoint. You activate this. In the infrastructure as code, there are 2 lines that you need to write, but basically understand that like a checkbox. So once again, currently only available for Lambda managed runtimes, not available for all other Lambda runtimes, even Docker container image. If you can put Java in the Docker or everything that you would like, it's not available. And there are also custom runtimes. That's a way how do we ship Graal VM native image. It's also not available there, and it's also not available once again outside of Lambda. I will show you some measurements of how it works, but basically what's see it as normally we deploy Lambda function and then we invoke Lambda function. But in case we enable Snapstart, the things will be going different. So then the Lambda phase kind of life cycle will be divided in 2 phases. So during the deployment phase, where you simply deploy application, if we have Snapstart, then there will be additional things happen. AWS will start on separate machine, practice their Java environment with that function and execute all steps required in the cold starts, like downloading the code, starting the JVM, initializing all the static blocks, but not invoke the function handler itself. That will not be done. Yeah? And after initialization of the code, they will take the snapshot of the whole execution environment. And in case of AWS, it's Firecracker micro VM. So they will take the snapshot. There are hooks we will be talking, they are optional. And it's in the deployment phase. In the invocation phase, in case Snapstart is enabled, then the restore of the snapshot will happen. There is optional hook, and then the function will be executed. So what's the promise here? Of course, that especially snapshot restore will take less time than the normal cold start. Otherwise, it doesn't make any sense. You will not then activate Snapstart. So people who are in the Java space may be aware of, yeah, snapshot, I heard something. There are technologies, Creo and Crack. It's what AWS does is not Creo, it's not Crack, but the idea is similar. Creo as technology is available since 12 years just to move containers around. And Crack is the project by Azul people basically for snapshotting and checkpointing the JVM, and Crack is based on Creo. It's a separate technology, and they have similarities, also differences. So Firecracker snapshots the whole running operating system. As far as I know, Creo snapshots single processor. So completely different stuff, but AWS produces Firecracker, so they control on Lambda the whole environment. So this is just to relate the stuff. What's important here, the question is what you can do with those hooks. So the idea is to put into the snapshot as much as possible, loaded classes and all that stuff, just simply not to waste the time after the restore. So then put as much as possible to the snapshot, and then we can restore the things. The snapshot, interestingly, they implement Crack API, but with Snapstart, but it's not the Crack technology. It is basically only the API that allows us to execute this stuff. It's only 2 methods before snapshot is taken or after the snapshot is restored. So basically, what we can use with that snapshots, there is a technique called priming. So we can prime, preload stuff, as I told you, as much as possible. what can be preloaded. For example, if we talk to AWS services like DynamoDB, simple queuing service, simple notification service, we need to establish HTTP connection. We need to initialize HTTP client. By default, it's Apache. And it turns out that this is costs several hundred milliseconds one-time initialization, because all this HTTP client and all that stuff is written or designed for the long-living applications like web application servers. There is caching involved that needs to be initialized. So these things can be kind of pre-warned. The second stuff is we are talking to different services like DynamoDB. We store JSON files there. If we are talking with Java, we need to convert Java objects to JSON or other way around. And this involves by default Jackson marshaller, and it suffers from the same problem. It takes several hundred milliseconds to be initialized once. So the idea is, in these crack hooks before checkpoint, for example, is to preload as much as possible simply by faking the call to the DynamoDB. This I will have somewhere this kind of method. This is get item by ID from DynamoDB. And I can simply fake it. The whole chain of classes will be loaded, HTTP client will be initialized, and Jackson marshaller will be initialized. And with that, I can just fill the snapshot as much as possible. So how does it look like? Basically, we need this OR crack dependency and implement resource interface. In the constructor, we need to initialize this Lambda function as a crack resource, simply copy this line. And then we have these two methods before checkpoint, before the snapshot is taken. And here I'm faking the call to DynamoDB by fetching the product with ID 0. I'm not even interested in the result. I'm interested in preloading the classes, and I'm interested to pre-initializing HTTP client and JSON marshal. Yeah, and after restore, I don't do anything. Yeah, so basically, I nevertheless have this method to get product by ID anyway, because I need it for my program, and basically I preload this. So now let's do some measurements with that. So this is without snap start. I already showed you this 3.2 seconds for P90. These are with snap start, but I did not do any priming. Yeah, I didn't want to prime this get product by ID. And the third measurement is with snap start and priming. So basically what we see, only by enabling, for my case, use case, but this case is quite frequent, only by enabling snap start, for P90, this yellow one, the call start went from 3.2 seconds to a bit more than 2 seconds. So 40% improvement only for checkbox. And if I could apply priming, and sometimes you can't, if you do something like math calculation or string concatenation, you will probably cannot prime anything. But in case of DynamoDB, I can. With priming, I can put the call starts for P90 to a bit more than 1 second, so from 3.2 to 1 second back. It's quite significant, to be honest. The warm starts, so the snap start is the technology to reduce the call start. So the warm starts remain the same, basically, with one exception. These max values are reduced with priming, because in normal case, if I don't use snap start, I did not prime everything. And then the first invocation, even the warm start, also takes more time because of this initialization of HTTP client and JSON marshaller. It always takes time. But with priming, I already primed it, pre-initialized that. So even the max value of the warm start will also reduce significantly. You see then the warm start, the max value is only below 400 milliseconds. So it puts then, I would say, in the call starts into the spheres where I can probably tolerate 1 second for P90. It's something that in case it only happens 1%, I think that's tolerable. I will show you only several things that you need to be aware of. I also asked myself, I did a lot of measurement, does artifact size matter? Without snap start, it was clear the bigger the artifact, the more call start it brings, because the artifact needs to be downloaded. The bigger it is, it takes more time, and the bigger the artifact, the more probably needs to be initialized. But I also wanted to test, is that true with snap start? And it turns out, yes, it's still true. So if you have kind of my applications, the medium one, 18 megabytes, but hello world application, which nobody writes, can be written with 130 kilobytes. And I also did some kind of big application, designed big application, and you see it's only P90, but you see the bigger the application, also with priming, the bigger the cold start. So it's true for all serverless application. Put only the dependencies that you really require, and don't put, for example, the JUnit test and so on. So the scope should be test, so you use it only for testing, not for live. There are other stuff, many stuff that you need to take care of. So, for example, as I told you, you can set the HTTP client. The default one is Apache HTTP client. AWS gives you two more options: URL connection, which is also standard one, and AWS implemented AWS CRT HTTP client. So this is the native stuff with C++. They did it 2 years ago, even before SnapStart. And you can set this, then you need this AWS CRT as a dependency, and this is CRT client is more designed for short-living applications, where like serverless, where Apache and a URL connection are designed for more long-lived applications. And what you see, it's not a surprising picture. AWS CRT client outperforms all others for two use cases. And in case the priming can be applied, then it doesn't matter a lot, because HTTP client is pre-initialized anyway. It doesn't matter what you set, it's already pre-initialized in the snapshot, so the results with SnapStart are quite close. So no surprise, but in case you don't want to use SnapStart for some reason, AWS CRT is a good choice, and you would like to talk outside of the world, probably also. There are new stuff. AWS released SnapStart. There are two choices to select architecture on Lambda. The default one is x86, but there is also ARM64 architecture, and AWS has its own Graviton chips, Graviton hardware. The thing was that SnapStart was for 1.5 years only available for x86, and now since July it's also available for ARM architecture. And I wanted to test it because the Lambdas running on ARM are approximately 25% cheaper than running on x86. There are different pricings, and as AWS controls this Graviton and all that stuff, so they make it cheaper. The question was, is it worth doing? Because Java is write once, run everywhere, so I don't need ARM machines. I can write the code on x86, compile it, and then execute on ARM, and it will work. So what I found out, the call starts are quite much bigger with ARM64. So you see, depending on, this is without SnapStart, is with SnapStart without priming, this is with both, it's only P90. So you see, it can be up to 25% slower for the call starts, but 25% cheaper. For the warm start, the difference is not quite significant, but yeah, between 4 and 10% slower are also warm starts for ARM. So it's then up to you. Maybe you can give more memory with ARM than 1 GB, like 10% more memory. Then you will put down the call starts also a bit. With more memory, you will probably have less call starts, but it will be 25% cheaper. So it's then up to you just to find the right balance. With ARM architecture, it gives you some options here. So what's important here also, I showed you, I see there were questions. I don't know, should we cover them now or in the end? Because I see now for 2 people in the end, yeah? Okay. So what's also interesting, and it deserves its whole talk, how this snapshot is really taken and stored. So basically everything on AWS will be snapshot, it will be encrypted and stored on S3, but they stored it on the tiered low latency cache. And if you think, I wrote the blog about it, and watch the videos, I will give you the link. It's an amazing technology because the snapshot can be 3 GB. So how is that possible that 3 GB snapshot can be loaded within 1 second? So we have only call start below 1 second. And AWS people talked about this, and what they are doing, the snapshot is divided by pieces, like 512 megabytes. And what they found out, that these pieces might contain the same Java version, which is shared across many people, the same operating system version, which is Amazon Linux in that case. And what they did, they put these pieces, they share it across everybody who uses the same Java version, like Java 21. And they only, of course, what they cannot share is the pieces that is kind of cached your function. And what they are doing is, if you, the first call start with snap start will be slower than, and with subsequent one, they become even faster because they fill this cache with your pieces belonging to your function. So I saw people who tried several times, did several measurements and say it's still slow. But after 10, 20th invocation with cold start and snap start, you see it's quite quick. It's become really quicker. And if what I showed you, were the whole 100 invocations from the function which been kind of deployed for the first time. If we only take the last 50 invocation, kind of, which were quicker because the cache is filled, then we see even that P90 call start was 700 milliseconds. And sometimes you have the function that you don't touch for months. So what are the first 20 executions? Nothing. Yeah, and they patch it beyond the scene. They patch the Linux, they patch Java versions and all that stuff. So it's an amazing piece of technology. And you can watch the talk by Mike Danila from Info, who gave this talk this year on InfoQ. He covered AWS Lambda under the hood, but he also covered the details about Snapstart and this cache. It's really amazing how they did. It was the multi-year journey basically for them. So I encourage you to look into this. But of course, each technology has challenges and limitations. For example, snapshot taking phase is not for free. So during the deployment, the snapshot will be taken, and it takes approximately between 2 and 2.5 minutes to take the snapshot, to secure it, to encrypt it, and put across availability zones in AWS. Sometimes you deploy multiple functions, or very frequently, then the snapshot will be taken in parallel for many functions. So that basically between 2 and 2.5 minutes will be this still true. There are things currently, for example, snapshot will be deleted from the cache if the function isn't invoked for 2 weeks. So it's not very well suited for staging environments where you don't frequently invoke Lambda functions, because then if you invoke it after 2 weeks, you will run into the error, and then the process of snapshot creation will be started. And for the duration of 2.5 minutes, you will have an error. For me, it's not very good behavior. I would prefer the normal cold start. I talked to the AWS people, but currently it's the behavior, but edge case. Of course, Snapstart provision concurrency doesn't work. You cannot use NFS-based system, Elastic File System. You can use only S3 if you would like to use Snapstart. But for me, it's okay. So once again, these are limitations, but the technology is really amazing and brings cold start 70% down. So let's talk briefly about GraalVM, because it's universal, and then we'll be also covering that. Probably everybody who is in the Java space will probably know it. It has so many different goals, but what is important for us is this GraalVM compiler. It gives us the possibility to do ahead of time compilation, and with ahead of time, you put everything kind of which is reachable method fields classes into the native image, basically produce native image. GraalVM is capable of producing Linux, Mac, and Windows native images. Of course, if it's native images, it's already precompiled, partially at least, and of course, it's just the idea is that it will reduce the call starts, but also memory footprint, because natively precompiled, there is no JVM in between, and it only contains what we will use. The situation is, of course, Lambda doesn't support manage GraalVM. GraalVM is a separate VM. It's not JVM, and AWS doesn't have currently, at least currently, GraalVM native image managed, but it has custom runtime. And with custom runtime, you can deploy GraalVM native image. It's basically zip function which is required, and it needs to contain within this zip bootstrap file. In case of GraalVM, you build the native image. I will leave the details how to build it, but basically you build native image, name it bootstrap, put it in the function zip, and say I would like to deploy it as a custom runtime. So I will omit the steps. It's worth another talk how you can do it, but there are so many ways. But basically, if I now will put the measurements for GraalVM, then you see the first three we covered. No snap start without priming, snap start with priming in GraalVM. You will see that the cold starts are by far the lowest one with GraalVM. You will have half of the seconds, and you see even the P's are quite near to each other. And it's not only the cold starts are much quicker, you also see that the warm starts are kind of much better. With GraalVM native image, especially, you see this P99.9 in max values. Yeah, even with snap start and priming, we could achieve something around 400 milliseconds. Here, we are below 200 milliseconds. So this is something which really sounds promising. But of course, you need to take care of lots of stuff. Yeah, for example, you need to put things into the so-called reflect JSON that will be loaded dynamically, because you need to put it into the native image, because otherwise you cannot dynamically load classes. So it's a bit more work. Things are known that you need to put. For example, all Lambda functions needs to be put, because they basically will be kind of from the infrastructure as code. There is a path, and it will be kind of loaded dynamically. All your entity object like product belongs to this. Also Yoda date time needs to put there, because API gateway converts that's from string to they use really date time and not Java 8 stuff. So there is a bit more work, especially if you're doing for the first time. You need to figure out what to put, but basically this is the known stuff. Of course, we in many cases use some libraries, some frameworks, and GraalVM has the page there. They say these frameworks are GraalVM battle tested, so there will be no effects on the runtime. And four mostly known Micronaut, Quarkus, Helidon, Spring are there, and they also put the dependencies. Sometimes we use certain open source projects in with certain versions, and they put what they have tested, because sometimes the one open source project has dependencies to others. We don't control them, and if in one something will be changed with some dynamic behavior, then we will have runtime errors and need to put this stuff once again in the reflect JSON and all that stuff. So conclusion to GraalVM: powerful without any doubts. The thing is, it requires Linux, because custom runtime on AWS Lambda requires Linux executable only. Yeah, so even if GraalVM native image is capable of producing other native images, AWS only supports Linux. Build time is also the factor. I require for the same application 6 to 10 gigabytes of memory and 2 to 3 minutes to produce this native image. So that's similar to the snapshotting with snapstart from the timing perspective. But of course, because it takes so much memory, it puts the pressure on your CI/CD. And that's why I appreciate AWS Snapstart to be fully managed, so because they take snapshot and manage that snapshot on behalf of me. In case of GraalVM native image, I will need to pay for CI/CD with auto scaling, that it produces multiple images in parallel, which will probably require, it requires a bit more. This is kind of the trade-off. So basically, just to put it together, to wrap up, both technologies, AWS Snapstart and GraalVM native image, reduce your cold start with AWS Lambda in Java 21 just to the, I would say, acceptable ranges at least. If you are willing to accept slightly higher cold and warm start, I will prefer to start with fully managed Snapstart with priming. If your business requirements say you need to just squeeze every millisecond from your Lambda function because it's business sensitive stuff, then GraalVM native image is the way to go for you. So I didn't talk about crack and all that stuff because it's very difficult on Lambda. And I think Dan will also cover a bit about Project Leiden, which is quite exciting stuff, which comes into the Java platform. I am currently not quite sure how it might work with Lambda, because all this class data sharing, crack, Leiden require that you start something, do some snapshotting, and then start from the snapshotting. With normal Lambda, it's not possible for the life cycle. I cannot control that. Either will need some emulator locally to produce the snapshot and then put the snapshot somehow into some storage that Lambda can access, or Lambda should support it natively like they do with Snapstart. Like the snapshot will be taken, for example, with class data sharing. It doesn't matter during the deployment phase, similarly to the snap start. So I see a lot of excitement, but I think on AWS we can only benefit if AWS will support it additionally. And I'm not quite sure will they do it or not, because they have their own snap start. But it's interesting time, and I see that the things might move into the right direction. The last word of caution before we can go in Q&A. All examples, you see the links below, I can share the slides, are on GitHub, but measure it not only for your use case, you can even download my code and have different results. I hope only slightly different, even better result. What are the reasons? I tested that within the last months, and Lambda has its managed Corretto Java 21 in certain minor version. AWS patches it all the time, so you will have another minor version of Java 21 for sure. And it can have different trade-offs towards cold and warm start. Lambda snapshot create and restore can improve beyond the scenes. So snap start can improve, hopefully into the positive direction. Firecracker VM improvements and so on. With GraalVM, I tested this even with GraalVM 21. We have now GraalVM 23. So there are things that are beyond the scenes, and Lambda still uses servers, and Java memory model impact is also there. You can have a bit different results whether we hit the L caches or RAM, and so that might be some differences, but I think the direction or I will see the ranges that you will have are there, and I think these are acceptable. I don't expect values that we can have with the cold start with Rust with 300-400 milliseconds. I don't think that it's possible to achieve with Java anyway, but something that is in the range of 1 second for the cold starts happening not too frequently, I think it's a good result. This is basically what I wanted to share. Sorry if it took a bit more time. And I think it's now the time to answer the questions before Dan jumps in. I can read them by myself.
What do you think is better? Like normally we have Q&A at the end. Can you stay with us, or you have to go? It's quite late where you are.
I will stay. I enjoy, and I will stay. We will do it.
So if people watching on YouTube, it's going to be easier to follow through, and then we're going to do the question, if that's okay. Like
it's completely okay.
Okay, beautiful. So you're right.
Then I will stop. Yeah, I will stop sharing so that the Dan can start.
Thank you so much, and thank you for the idea. So this topic really came from Vadym. You're the one who approached me to organize this, so much appreciated. So then it's your turn now.
Thank you. Just let me know if you can see my screen.
Yeah, it looks good.
I don't see actually what I'm sharing.
Just the slide, the high performance Java.
Yeah. So I'm going to also show you a live demo, and let's get started. So this was great, Vadym. Like I learned a few things. Like probably I haven't seen like any live talk explaining how snaps start work. So very helpful to me. So let's switch a little bit to the Google world. I'm going to share I'm sharing actually my laptop screen. If I'm not looking at the camera, I'm not going anywhere. So with serverless, we started, developer teams love serverless. Fully managed, highly scalable, open standards, easy to onboard. But of course, there are always some challenges. Whenever you want to improve performance, you're always thinking, well, CPU and memory come the first one to mind. You might have just some limited computer configuration. How do you control scalability? And we already started the discussion on cold starts. Now, we have to aim for something today. So we want to understand what can trip us up. And we want to see what we can optimize in serverless. And if there's Kubernetes, does the same thing apply there? So I'm Dan Dobrin. I'm an app architect in the North American technology team in Google Cloud. I do have the privilege of working with customers, not just on the continent, but also in Europe and around the world. And that gives me a little bit of an insight of how teams are trying to adopt serverless, what pain points they're trying to address. One of them being Java in serverless. And of course, there are performance issues. Can we mitigate them? let's see where we start, and let's see how fast we can get it. So if we want to base the entire discussion on basic arithmetics, optimization is a sum of multiple factors. The runtime environment where we run. In our case, now we're going to focus just on Java. It's the Java runtime, the frameworks, the extension, the Spring Boots, the Micronauts, the Quarkuses, and then last but not least, our application code. Developers, when I'm talking to different developer teams, there are a number of questions which come to mind quite often. Why do my services start slow in serverless? Why do I see a high number of service instances? My container is not accepting traffic. Performance drops off over time. And everybody would like to know if there's a one-knob optimization. Now, we started building 12-factor apps, and now there are 15 since API-first telemetry and authorization authentication has been added. And if we look at them, we always want to think in the serverless world that one comes to mind. For me, disposability. All of them are valid, but disposability is important in the serverless world. Because if we quote Nicholas Taleb with his anti-fragile book, a system under stress has to come back better than it was before. So we're not planning on a service being up, but we plan on not losing data. How quickly can we restart? It's a distributed environment in which we're operating nowadays. So we always have to find a balance. This image stuck to me for years. It's from Gregor Hoppe, as in enterprise integration patterns fame, where he was always advocating about finding a balance from like startup time, resource consumption, concurrency, container image cost, all the way to throughput. And we have to balance them all out. We are working in the real enterprise, in the real world. So there's always a balance. That's we would like to have an ideal solution, but we also have to balance things. In the serverless world, one thing we have to put to bed quickly is the problem of scale to zero is the same as the problem of scaling up when it comes to cold starts. Whether it's 0 to 1 or 10 to 11, the problems are the same. Now, before we can look at the sum and how we can optimize each of those factors, we have to understand our cloud runtime environment. In Google Cloud, the serverless environments are containerized, and we can run them. Cloud Run is the main service. And Cloud Run, since we released recently Cloud Run functions, you can have now a function service running as a containerized environment. But in Cloud Run, what types of services are we going to run? Some are services which reply to requests and events, HTTP traffic, and for those, cold starts might be important. But there are also jobs which take a task and execute it to completion, where throughput and longer-term optimization come to mind. So we have to address them both when we're talking about Java performance in serverless. Cloud Run is available in all regions, as well as it will be available in upcoming regions in Google Cloud. The first thing, before we even talk about optimization, we have to deploy something. So when we build our application, our unit of deployment has to be a container. If we have a container, we can decide what we put inside of the container. So first, let's focus on having a container because it gives us the ability to move workloads between Cloud Run and GKE in both directions, and organizations do that. These are OCI compliant images, and we can decide, once we containerize it, we have now the ability to decide where we can run that. Do we want to run it in Cloud Run serverless? But we might want to decide to run it in GKE, and we want to see if all these optimizations apply for every single scenario. Now, auto-scaling, which is an important factor in a serverless environment, no doubt about it, is impacted by multiple factors. CPU utilization is one of them. In Cloud Run, once it hits 60% of CPU utilization, an auto-scaling process starts. Now, it starts not just with one instance. It depends if there's an influx of resources, it might start more than one. But as you pay only as you use them, that is, in fact, a proactive, beneficial step. Now, auto-scaling, we could have a number of provisioned instances. If we don't want to scale to zero and we want to have always not incur on occasion when we switch between types of loads, let's say maybe reads versus a lot of writes, like a bank does maybe between during the day a read and updates more at night. You can have provisioned resources, no minimum number of instances, as well as you can cap them to a maximum number, the reserved number of instances. Now, auto-scaling is also impacted by the request concurrency in that particular image. One important thing to know is that CPU is allocated when we process requests, but if we have background, and we pay only for what we use. If we want to do background processing, which are not in the regular flow of an HTTP request, then we have to turn on CPU utilization. And yes, we pay for that. But in a serverless environment, we always have to balance what our application needs. If we want to write logs once every 100 requests in the background, then we should be cognizant of that. Now, concurrency, as this is a containerized application, and concurrency is not just one instance per one request. Concurrency plays a significant role and can impact directly our cold starts. Why? Because if we have a one-to-one mapping between instances and concurrency, think about it. If we have 400 clients making 3 requests per second, we might need roughly 500 plus instances to serve them. But if we use the default concurrency of maybe 80, which is in Cloud Run, of course, that depends on various factors, then the number of instances is reduced because one instance can process multiple requests, and that requires less cold starts for us. One feature which Google has introduced a couple of years ago, and I measured it personally at that time when it was still in private preview, is CPU boost. A number of languages, it's not just Java, but also, for example, a Python application loading AI/ML modules require significant more CPU during the startup than at runtime. Why for Java? Because of dynamic reflection, dynamic proxying, resources, serialization, and CPU boost increases the CPU allocation during the startup until your startup probe succeeds, plus 10 seconds. And with that, it significantly drops the performance, it increases the performance, it drops the startup latency for a Java service. And we want to see all of these in running. We're going to run the demo in the cloud. How will we run it? We want to see a relative between the different environments. You can try each one out in your particular environment. But CPU boost is an easy feature. It does not require you to make any changes to the application. It's simply a configuration change. And sometimes it can bring you over the hump right away. Now, we want to optimize each factor. If we start from the bottom up, so the cloud runtime, we can increase the number of allocated vCPUs. In a serverless environment, we have virtual CPUs. So we can increase the number of CPUs. We can use a different runtime environment. Cloud Run has 2 of them, the first and the second generation. The first one was optimized for faster start. The second one has full Linux compatibility, network file system, a number of features. Use CPU boost. It's the simplest rule in the book and the biggest bang for the buck. Tune minimum instances wisely and proactively. If you need to, it's always based on your use case. Tune them wisely. And match memory to concurrency, because each request carries some memory, has some memory requirements. Whatever those are depends on our application. We might be running 2-3 requests in a container, but we might be running a lot more. The second one is optimize the JVM. And these recommendations are set as in almost like in copy and paste, and they have been tried and tested in production environments. Use always the latest LTS version. 23 is out, sure, I use it as well. I use 24 early adopters, but for any project which you put in production, use the latest long-term supported version, which is 21. Never rely on the default Java ergonomics. Set them always yourself. For example, Java until Java 8 build 192 was not container aware. After that, it is container aware, but if we don't set up the container memory, it will allocate it to 25% of what we allocate to that container. So we want to set that up with max RAM percentage. If you set it at 75 or 80%, it kind of like virtually covers all the use cases you might have. Set the garbage collector explicitly. G1GC is probably the best bet for the majority of your application, unless you have extreme low pause requirements. Why should you set it explicitly? Because if you set below 2 gigs, 1,762 megs to be precisely, Java will automatically allocate a serial garbage collector. And a few seconds or a few minutes in the run, you might be running into an unpleasant surprise, a full stop of the world. And reduce the thread stack size. By default, Java allocates a meg per each thread. If we run at maybe 50 threads concurrently, we could reduce that maybe at half or 3/4 of it. From experience, of course, that's just experience. 128 is sufficient for most applications. Now, in frameworks, and I'll give an example of Spring Boot, as it is the widest used web framework in the Java world. You want to limit unnecessary auto configuration because they will impact your startup time. Optimize class path scanning, optimize dependency management, fine-tune logging, and actuator endpoints, which will give us great insight into what is happening into our application, health endpoints, including thread arms, what different things. We should disable the ones which we don't need. Health and startup would be my favorites, and I think they should be always there. But the others, use them if you need them. Last but not least, optimize the application. Why? When we were in the app server days, like I was a BA architect in the WebLogic heydays, we would build application and load up a lot of stuff at startup. And we try to keep an instance up and running for days and so on, because it's starting up a WebLogic instance was like 5-6 minutes. And we would read up data like reference data, well-known data at startup. We should not do that. We can put a native image or any crack, native, light, and anything. If we make 2 database calls or one, we should be aware that we're going to pay a price. Eliminate unnecessary dependencies. Prune your image for what you need. Minimize the container image. In Java application, you can layer your images, and Spring Boot and Java by itself has a single command in which you can layer the images, and that would increase performance. Avoid calling services during startup. If you really need to load data, load it from a cache, but load it on demand. So I'm going to show you a demo. I'll leave the QR code and you can see that. What is this application? It's a web application, simple CRUD, runs against Postgres. What it does is it will get you quotes from famous people. So we said that a service is in a serverless environment is available to process a request when the endpoints are up and running. Always set up your startup probes, which in Spring you can set up with any post contract. So after when your controllers are up and running, this is when they're available to process requests. So what do we have here? So we have a number of services. I can make them a little larger. So a number of services, and it's the same service which I deployed in certain different configurations. And actually, let me start it, and then we will run this against US Central 1. I usually run it in Europe and in US Central 1, but of course, that's great. While Vadym was talking, my IntelliJ crashed. That's for changing a new version. So let's run this. Let's run this request. How did we configure it? So we have all these services. We start giving it 1 CPU and 1 gig of RAM. Then we want to increase CPU, want to increase memory, and then we want to increase CPU, but also give it CPU boost, because if CPU boost truly works, it should work with less allocated CPU. So we'll give it only 1 CPU, and we have to see that performance has to be at least the same as with 2 and 2. So if we start with this configuration and we see 1 CPU and 1 gig. For 2 and 2, we will give it 2 CPUs and 2 gigs of RAM. If we use CPU boost, we will set this as 2 and 1, but enable CPU boost. It's one simple checkbox. Of course, you would script it when you deploy it. Then we want to set up tools, and we said we should set things up explicitly. So we set up G1 GC. I set up max RAM percentage to 80. Always set up the active processor count. Don't rely on the environment to set it up within the JVM so that it is properly configured. Prevention is always easier than fixing afterwards. And Vadym used the same settings of tier compilation, and I reduced the threat act. These are general best practices which apply in any kind of environment. Then we want to increase CPU and RAM and see, are we getting actually any benefits? So until this runs, all right. So we ran these requests. So let's see. We have a number of scripts, which first I'm going to get the logs from each one of the service, look for the start, look through the last 100 logs, and we're going to let's start this, and we're going to look at them one by one. So it gets all the services, but it's going to filter the values which we are interested in. So let's see if what we were hoping for is actually holding true. So if at 1 and 1, it starts in like 22 seconds. That's not really acceptable. Well, if I increase memory, there's a small improvement. Now take these numbers as a relative. And I did not tune the application to the hill. So kind of like a stock application, but going to the database. And then I'm going to add CPU boost, and only one CPU. So I see that between 2 and 2 and CPU boost, it is even slightly faster. So by just adding, if I need CPU only at startup, by just adding CPU boost, I bring this down from like 20 to 9 seconds, which in many cases might bring us under SLAs. If I'm adding tools and I tune garbage collection and a few parameters, there's a small improvement, like a 10%. I get it down to like 8 seconds. But if I go down to 4 and 4, it's now it's randomness. Between 2 and 2 and 4 and 4, from a startup perspective, there's no real difference. There's no real difference for us. So all these improvements hold true, and they're easy to achieve for us. We can do that for any application we want. So if these are regular things, what would be the next step? Now we're getting into the newer things, the fun stuff. Well, we'll see if it works. So one is class data sharing. It's a JVM feature which would help reduce startup time and memory footprint. It is actually available since Java 5, but actually not very much used. It caches class metadata in an archive file, which it would preload quickly. So it's only your class and class metadata. No data, no specific data like secrets or other values, which are a problem in native or crack. So it will cache system and application classes, but it relies on a training run to exercise the startup and the warm up code path. Why should you use it? Because it's production ready, it's mature, and it improves all the time. It does not cache the initialized values of static variables. That's super important for us because there's no risk of leaking secrets. And there are less constraints and side effects than GraalVM or Project Crack. In spring, since May, when Boot 3.0 came out, there are a number of great features. So you can exercise at least the startup, when it does all the reflection and dynamic proxying at startup. You can start it with one flag, and once it finishes getting the context, it will capture a snapshot, save it, great. Could you also exercise a training run? As Vadym was mentioning, you run a training run in the AWS environment. Yes, you can improve that a bit more. But if you want to be risk-free and be able to script this in a build system, an easy thing to do. Are there any trade-offs? Well, nothing is free. So the JVM and the class path which you use when you create your archive has to be identical with the one at application startup. You have to decide when and how to do the training run. If you do it in a build system, maybe you can't run integration tests, but at least the bulk is during the startup. The improvements are not as significant as GraalVM or Project Crack, but it's quasi risk-free. Now, there are many applications where a serverless app has an SLA under a second. So here's where we need to see if we can achieve that. So we need some next level performance. In a native image, let's compare them. More work at build time, less work at runtime. In a regular JIT environment, we compile our code, archive it, run it. JIT compiler takes over. As we exercise different passes, hotspots will be compiled to native code in our execution environment. When we build native images, we build things ahead of time. So the same process of building a jar archive, but then we transform it in a native executable. We start from the main and analyze every conceivable pass which we have. It does a closed world assumption, and we know when we build that image that that's everything we know about it. There's no more dynamic part in it. Well, we'll see if there's something to be done with this later. But it takes, of course, more work. You can see that, but the native runtime much faster because now we just have a native image. And that native image we can put in a container. If we take that image, we put it in a Docker container, we can run it in serverless, we can run it in GKE, it doesn't make any difference. So native images do not require a JVM anymore. They're specific to the OS and machine architecture. They're compiled ahead of time. The images are smaller because we take only the classes which we actually need. The images are smaller, and also the RSS memory consumed is less because we don't load more in memory than we need. Now, is there no JVM? There is a very fine layer called substrate VM, and it was in Vadym's diagram, which would help run things. But if we look at the image, this 200 meg layer has disappeared, and it is replaced with our application. Now, why should you use it? Because you have super fast startup. Peak performance is from the first request. Request number 1, request 1000, the same latency. Of course, executing the same request. Smaller container images. The lower CPU and memory usage makes them greener. If we think about it, we use less energy. And there's a smaller attack surface because the amount of classes we have is actually smaller. From a security perspective in an enterprise, that's very important to us. Are there trade-offs? We said there's more work at build time, but that means quite significantly more work at build time. Depends on the machine you have. A Spring Boot application, this application builds on my machine as an image in maybe 20 seconds. Build from clean, containerized. The native image builds in like 2 minutes. 2 minutes something. Now, should you do that, build a native image all the time? No, but you should be aware that there is a trade-off, significant trade-off in terms of execution, in terms of build time. Now, there are closed world assumptions with AOT from the beginning, and from some older libraries where we cannot find the passes, some additional shared metadata is required. The GraalVM team has this great repository where every library contributes. Some of the things might not be there. Or if you build an AI application and use function calling, then you're building new functions. Those have to be registered as well. Now, what is the alternative to native Java? The alternative for the time being is Crack. On the JIT side, we understand how this works. On the Crack side, and Vadym explained that, you have the application, you will checkpoint it, take a snapshot of this, and then you restore it in the execution environment. Now, where can you do that? Google Cloud, you can run it in a build system. You just need to run it on the same machine architecture as the one on which you run. So you run it on an Intel x86 in the cloud. This is where you can run the image, and we're going to run this here. So once we have the image, that image we put in an artifact registry, the same container registry, and then we can deploy in the cloud. It's a Docker image, the same Docker image, which we can also, we have the choice of where we want to deploy. The startup time is super fast, not exactly as fast as native, but super fast. Peak performance from the first request. Now, if you checkpoint it right at the start, same as with CDS, maybe you lose some of the, not maybe, you will lose some of the performance. If you pre-warm them and checkpoint it, then you have a fully warmed image and you have peak performance from the beginning. Easy developer onboarding, but as Vadym mentioned as well, you have to implement an interface because you have to, objects don't survive a snapshot. So file descriptors, database connections don't survive a snapshot. So we have to close them gracefully and restore them. Frameworks, Quarkus, Micronaut, Spring are all working on doing that transparently for developers. Are there trade-offs? Yes, you have to checkpoint and store the Java application up front. Now, again, we talked about peak performance depending on when you do that. And you have to close resources, reopen them. Again, the cryo dependency. You have to be careful that if you have, for example, a random number generated, which you use to generate a sequence, and you save that in a final variable, in a static final, that you have now created a security leak because it will generate the same sequence over and over again. You can do that, unfortunately, in native as well. But these are things which we have to learn and deal with. It's not something which cannot be overcome. We just have to learn new best practices, and that includes security. Now, okay, startup is okay, but how about peak performance? Because that's in serverless. That's why we talked about jobs. It's not just HTTP requests. There might be long-running jobs. Let's say you run bin packing algorithms or AI, ML processes. The choice is yours. So there is one feature which was added in Grav, which is PGO. It's profile-guided optimization. So the JIT compiler analyzes the behavior at runtime. The ahead-of-time compiler analyzed as a static analysis, but has no profiling information. So PGO gives the AOT compiler both a static view and a dynamic view of the application. So the end result is the optimized app performs better than the default AOT compiled app. If we look at it versus Hotspot, and the numbers have been run, this is a courtesy of the Graal VM team, you get slightly better performance than even with a JIT compiler over a longer execution of time. So let's try this. Out. So we're going to run these requests. Now in here, the difference when we run them, there is nothing out of the ordinary configured. We give it two gigs of RAM, 2 CPUs. Nothing really out of the ordinary. So not a very high, regular configuration. So these once these run, we should let this run. While this is running, let me. All right. So this has been run. Let's see now. So we have, we want to see where the numbers are. I ran also the test for the last batch, so ignore what I'm going to say up to a point in terms of numbers. So it grabs all the other logs so that we can see the natural progression. So now we went to CDS. CDS brought it down. So this grabs the last 100 logs. I ran it also to ensure that everything is up and running before we started. So it brings it down now to a roughly from 10 CDS, from 8 seconds. That was the best we got. Brings it down to 3.6. And with crack, we bring it down to 2 seconds. And with native images, we bring it down to roughly 1 second. And with profile guided optimization, we bring it down to sub-second. So it's the same app, but now run with a native image and full PGO in the same region, in the same project. We started from 20 seconds. We bring it down consistently under a second. That is important for us to know because it addresses use cases which we could not address earlier. Now, what does the future hold? And Vadym started mentioning Project Leiden. Is this a magic solution one day? A year ago, when the Oracle team always joins DevOps Belgium, and that's a great point to listen directly from them, what they're coming up with. It sounded a little bit like futuristic. In spring, when I tried out at Spring during Spring I/O with an early, like a pre-main, it's not even in the main branch, it was already promising. Now it's becoming close to spectacular for what we get. So Project Leiden wants to improve startup and warm-up and footprint, and it wants to shift some computation earlier to build time, ahead of time compilation, CDS. Yes, it will constrain Java's dynamism, like it does closed world assumptions. But now if we think about it, if we can shift parts of it, maybe we have only our little application layer, which we don't want to subject to a closed world assumption. So we can shift parts of it. The intent is from the beginning, 100%, to preserve the meaning of the resulting app as the original, regardless where we shift things in time. And so we want to be able to select which aspect can be shifted and which can be constrained. Now, the new feature, which was discussed the first time 2 weeks ago, we have it running. I got it running a few days ago, and I'm going to try it out with all of you. So AOT cache merges, and it's work, and there's a JEP, a Java enhancement proposal out there. It's a collaboration between Oracle and the Spring team. So CDS was introduced in Java 5. And AOT, which does ahead of time compilation, and Quarkus and Micronaut all do it, not just Spring Boot, for native images, they are merging their ideas. So ahead of time compilation can be used not just to replace CDS, to cache all the metadata classes in their system classes, but can also be used to cache the classes using the same process during warm-up. This would continue to be improved, but this collaboration is and CDS will disappear probably after, I don't know, let's assume Java 25 next September or maybe later, but CDS will be replaced with this idea of an AOT cache. So if we look at the numbers, I ran these earlier. So I ran the same code base. I ran this in Spring with Leiden at that time, and it runs now, but it's the code base, still Java 21, has not changed since. It's running in the 3 seconds. But now, as of a few days ago, you can bring it down to 1.5 seconds too. So it brings it down to crack values. It brings it down to crack values and very close to native. This is going to be great because we have to think in the enterprise, we want to reduce risk as much as possible. And we can mitigate risk. Now, is this going to be available? Should you use this in production? No. But just follow it, because this is going to be a very useful feature. And now we are going to have choices. Right now we can tune the environment, but we can have CDS, we can have native, we can have crack, We can see what Layden brings to us, and they all run in the same container application, in the same environment. Those are immutable. So when we build apps, we should think like the late politician Donald Rumsfeld with his known knowns, known unknowns, and unknown unknowns. We do not know what different teams want to build, what technologies they're familiar with, what they're comfortable with. So we should provide choices. That is the important thing. Now, if we were to make recommendations, there are two recommendations from our perspective if you would run that. And again, I think they would apply equally in both a serverless environment like Cloud Run as well as in GKE. First, let me just compare them so that we see what we've done. Startup, we start from native, instant startup, CDS is faster, and Line much faster than CDS. The warm-up is instant in native. In Crack is instant, and with training, we get peak performance. With CDS, no difference because it gets executed at runtime. With Leiden, it becomes faster with training. The peak throughput with PGO. And in the past, there were questions asked about the Oracle GraalVM licensing. The license, as of several months ago, it's called almost free, which means unless you resell your software, you can use for free the GraalVM license with G1 GC in a production environment. Memory consumption in Graal is lower. In Crack, it is the same. With CDS, it's slightly lower. With Project Leiden, it is a bit lower, but take it with a grain of salt. This is in preview because teams have focused on startup rather than memory optimization. You can't optimize them both at the same time. Compilation with Graal, absolutely much lower. It is fast for all the others. Reachability that metadata for is required for compatibility. For Crack, restore works because it's based on Creo. It requires Linux. For CDS and AOT cache, you might have training side effects, which we have to be aware of. Security is better with Graal, and the container sizes are smaller with Graal. They're larger with Crack. Imagine if you take a 200 meg image. Once you start it and you checkpoint, it might get up to 600, 700, 800 megs, but you have a full running image. And with AOT, with Project Line, it is much bigger for now. To quote the Oracle team, the same, they tried it with the pet clinic. It was 100 or 130 megs larger. Now, if you're on the JIT world and you just tune your environment and your application, virtually the same as we're used up to now, please use Java 21. The JIT version of Graal has native and JIT. The JIT version is 10-15% faster than OpenJDK for free. The GraalVM team and the OpenJDK team are coming together in Oracle, and the Graal JIT is 10%, 15% faster. These are the numbers which the Oracle team is providing in conferences. And use AppCDS. This is production ready. You can use it. If you have that magic one knob, if you would have one single choice, use Java 21 with GraalVM, use PGO, the G1 garbage collector, and use maximum optimization when you build the GraalVM image. It could start from almost no optimization, optimized for size, but if you want full optimization, and then the build might easily get into 5-6 minutes. This is true. But we get great performance. We get sub-second. This is production ready. So thank you. I'm going to stop sharing this. But the idea was we explore different things and we look at it from various angles. But what is important, developers need to have choice and need to build the applications they want to build for the environment and the use case they want to build it.
Thank you, gentlemen. Just amazing. So, Vadym, thank you for the idea for this meetup, and then thank you for joining in and like a professor covering all angles and different cloud. So we can start with Q&A. There were some chats, questions in the chat already. So, Vadym, you want to take it off first?
I tried at least to answer the questions in between, providing different links. Give me a second.
And feel free to repeat for the people watching on
Okay,
YouTube. They will not have access to chat.
So there have been questions about what is priming, and Daniel answered this. Yeah, priming is kind of preloading as much as possible, pre-compute everything. Basically, you can do the same in the static initializer block of the Java function. Sometimes the code will look ugly, but the idea of priming with some kind of snapshotting, it doesn't matter, crack or snap start, is just put as much as possible the stuff. Preloaded classes, preloaded components, pre-initialized component, because as we saw, and then shows that the restore is much quicker than the normal cold start. So it involves sometimes just to break with the clean code, to think differently, just to see, okay, what I'm using, what can be optimized, what is behind the scenes, but many things becoming kind of public knowledge, what you can do, what you can't do. I showed the link about the priming guide from AWS itself. My dream is that it will become part of the libraries, that we don't need to write repetitive code for priming, because basically everybody does the same in the last things. Everybody pre-warms the same stuff. So it will be good if the frameworks, the platform will help here. Just we don't focus on that. We somehow pre-configure and say what we would like to have, but we just stop writing the same repetitive code. What I thought it was fired after retrieving the snapshot, but before the request, we can ask the expert.
Oh no, that was just me chiming in on the other thing. I wasn't sure, like, what was an example of something that would fire in the after hook? The pre-hook is when you put together what you're going to be priming and it gets stored in the snapshot.
Exactly.
What would you do in the after hook?
So it's the question, what can survive the snapshot? For example, with crack, as far as I know, file handles and all that stuff will not survive. So you will need to reestablish that. You will probably need to reestablish the connection to the database, to the relational database. As far as I know, snapstart doesn't need that. So for me, even the connection to the relational database, not only to the DynamoDB, survived the restore. I didn't have null, I had the connection. It's for me sometimes magic, but this is kind of the difference between snapstart and crack based on Creo, that much more things survive. But you need simply to check that. Yeah, just you will run into the error if you just restore and something is not there. Then you may think, okay, maybe it didn't survive. Yeah.
And Satish had a bunch of good questions for you in the chat. So one of them was, is it correct to understand that each Lambda function needs some service like cache start, DB connection? Please
Correct.
advise.
The Lambda function needs some services, like it depends what Lambda function is doing. Yes, in the AWS world, you're communicating in many cases with other AWS services, like for persisting the data. But it shouldn't be AWS service. You can use GCP for persisting into the relational database. It's another topic how serverless functions work with the relational databases. There are some issues with connection management, but they are kind of workable. So I don't know what is the cache start. Maybe you meant maybe Satish, you can a bit collaborate what you meant. Here, please advise other sources that can be part of priming. I then put and then answered that. Just you can try GPC connection, and priming can simply preload things, because Java has dynamic class loading. So the classes will be loaded when they are first required. Yeah, and if it's just in the function handler itself, then it's not the part of the cold start, it's a part of the warm start. And sometimes you can fake the method executions with this before checkpoint, before snapshot, just simply by loading the stuff. Because if you, it just doesn't matter. If you only need to load several classes, then the difference is not there. But if this invocation chain involves hundreds of classes that needs to be loaded, the difference will be quite significant if they are already in the snapshot. That's basically it.
Satish,
Yeah,
you're
I got
unmuted.
it, yeah. Thank you. Yeah.
Any other questions? You were quite active in the chat.
Oh, there was one. Okay. So you finished. There was a question on functions.
There are questions on functions.
Oh, Alexei was asking about Cloud Run functions and functions and in GKE. So the first version of Cloud Functions was here's the function code. You could deploy from source, or you can paste it in the GCP console. It will be deployed using Google Build Packs, and you had several languages: Python, Java, I don't know, Ruby, Node, and so on. Version 2, which came out 2 years ago, already based functions on Cloud Run. So you have the interface of a function, but the build packs would build a Cloud Run instance. Why would it do that? Because it allowed you to piggyback on Cloud Run features, like, for example, concurrency, setting up memory, a number of items which you could decide to, if you wanted to have that. Of course, if you had the Java function, you obviously did not want to have the cold starts issues, and with concurrency, you could easily mitigate that. Cloud Run Functions now brought this idea. Cloud Run Functions brought this idea that you have the function interface, but it runs directly on Cloud Run. Cloud Run version 2 is alive and well, will continue to run. But Cloud Run function now gives you, I have Cloud Run and I can just say deploy my container, but I can as well say I have this function which moves a message, listens to a pub sub, and writes to a cloud storage, for example. So that is the idea. In GKE, there's no cloud functions for GKE. Now, if you want to use a plain Java function and listen to or a Spring Cloud function and make it as part of your application in GKE, sure, of course, it's a programming artifact. If you want to use, on the other hand, the function framework, which is available to you, then you can use that in Java or any other languages.
Yeah, thanks, Dan. Absolutely. No, that was my question, because Cloud Run functions were missing, right? And I was asking Google.
Yeah, it's brand new. It's a month old, or
exactly. It looks like I missed it actually when I was I was about to ask the question, and then I recognized they were just introduced. Thanks, Dan. It's good. It's good that Google.
The main thing is there's a container. That's your unit of deployment. So by this, it creates like in an event-driven architecture, producer and subscriber, consumer of an event. Here's a container. I can build it, and there are the different things, the pros and cons, what I build, what I put native, JIT, crack, whatever you do. Once you have that image, you should control it with some tuning parameters, memory, CPU, arguments, sure. But now you should have the deployment, the choice. If you, and especially because serverless is the easiest way to get into a cloud, an application. But many times you might be running an application which you might want to run on GKE. If that's what you want to do, you should just change your deployment, and the deployment configurations are the same. Cloud Run is not a Knative implementation. It is respecting the Knative implementation spec. And if we look at things, you can see the spec, but it adds a number of features, CPU boost. If you increase the number of instances, it does not incur a revision. So consider it a Knative ++. So it respects the spirit. But you can export the YAML file and deploy like you would deploy in Kubernetes with similar deployment scripts. So in the end, we don't know what teams would build. So that's why here is a container. Now let's decide how we do it. But we have to work on the Java side, on the framework side, on our application side, because the cloud cannot do anything for us. We have to put our own efforts in, right? So that's why we look, both of us, at so many options and different parameters, because that is the reality. We're not like home free if we don't put an effort in.
Awesome.
Thanks. Makes sense.
Who's
I
going to shoot
also-
the next question? Go ahead.
I see that Satish also asked, is there any graceful shutdown sequence in Lambda? So Lambda is a function as a service, so it's different from containers, platform as a service. So the environment, execution environment, and we are talking about the Firecracker VM with managed Java. It can be managed Python for Python. They can only execute one request for the environment. Yeah, it's just not like web application server, which can scale until it's simply not able to execute. It's only one request, and then the execution environment will come back to the pool of execution environments, and is ready to just serve another request. Of course, that there will be no requests or less requests that there are environments, AWS and or other providers will release that environment, because for the cost reason, they cannot just stay forever. It takes 5, 6, 7 minutes on AWS. If you don't have any requests, all environments disappear. It works like this. With Lambda, of course, you can set the timeout on the per function base, and the maximum value is 15 minutes. But generally, if you have public-facing applications, it's about seconds, and you will run into timeout if you cannot execute. But basically, it's similar like the database connection in the pool. It returns. And sometimes it's just simply, it can stay in the pool or can time out in the pool. This is how the function as a service environment generally work.
Yeah, that's general in any cloud. And if we think about it, even 20 years ago in the WebLogic heydays, actually, WebLogic is still up and running, live and well in many places. So during a shutdown, you can capture the shutdown sequence. You can do that in Java now. And if you have resources which you might want to gracefully shut down, as Vadym mentioned, there's active instances become idle, and then they get evicted. When they do, Java shuts down. You can implement and you might want to decide to close gracefully connections or whatever your application calls for. But there's a clear point in time. And web framework like Spring has an apt pre-destroy. So before it destroys a bean, you can implement, let's say, you can gracefully shut down your data service or your messaging service, or you can flush things which you might not have done so. And other frameworks have similar mechanisms.
Yeah, thanks, Dan. That's a good hint.
That's awesome. I have a question if there are no questions in the chat. I think it's for Dan. So I stopped coding in Java in 2016. So that's probably one of the reasons we didn't have many of these meetups. But you light the fire again.
What a mess.
So, but like it would be more on the ops or DevOps side, optimizing legacy Java apps. So since I haven't touched it in a while, migration is out of question if you want to quickly help somebody. So you keep saying use the latest one, but there is 8, there is 11, I think 17, 21. Where would you stop if you're not a developer or you don't want to develop and break something by upgrading releases and still benefiting from Cloud Run?
So let's put it this way, and that's valid for every environment. Of course, in a serverless environment like Cloud Run, even more of a benefit. Java, if we look at all the versions, the one which had the greatest sort of set of features was Java 8. When it brought lambdas, it brought a number of things. But many applications, if we look at stats published by various companies, Java 8 and Java 7 are still probably 50% of the VMs. 11, 17, 21 come around. Now, when you upgrade, there are two things. One is, do I upgrade the source code level? So do I want to use Java records, which showed up in 14, or virtual threads, which showed up in 21? Or do I just want to improve the runtime? So the rule of thumb, if you have 8 to 21, you get a 15% improvement by just rebuilding your application. Keep your server source code at Java 8 if you're at 8. Updating the runtime is a freebie. Sure, do you want to run a test to ensure that nothing has changed? I have not seen yet a case where things just fail. If you keep the same dependencies, but you just use a faster runtime, it's a free benefit. Now, when you upgrade things, you don't need to use every single new feature. Do you like to use record? Sure, I like to use them, but it's not a make or break. Should you use lambdas? If you do a for loop, the classic for loop, like from the beginning, is still more performant than any lambda. It's just how things work under the hood. So if you take a new feature on, you take it because you need it. Virtual threads, great now with so many AI calls, with many operations. Many other features come along, and they will be super helpful. But upgrading the runtime is one thing. And of course, you get rid of more security. You address CVEs and security issues. If you keep frameworks at the latest version, it's not just you need to use that feature, but you have maybe leaner dependencies. Maybe you have less CVs. Sometimes you have dependencies of dependencies, which might cause you problems. And that's why you should be upgrading. What is important is how we test. And we should have always our tests run into play, maybe subject of another discussion, test containers. But it would be great for everybody to just keep things and update things, because there are multiple factors. It's not just performance, it's also security.
Mm-hmm.
It's other aspects,
Awesome.
which we should always keep up in mind.
Maybe to add how the things are on AWS. AWS has its own JDK distribution, Corretto, that they still support even with Java 8 for free, and they will support it until 2026, so it can be used to deploy it in EC2 or on servers, on containers. But for example, I cannot create any managed Java 8 with Lambda. It's not possible, since I think end of the last year they discontinued that. So I can only use 11 and onwards. And I think I even cannot run, if I had existing Java 8 function, I cannot run. So I need to update. The reason behind this is, of course, that AWS needs so many versions of each programming language to maintain and run and patch and all that stuff. And they're not only doing Java, they have others. So they simply raise the bar and say we need to kick out some older versions and just please keep up with updates. It's of course much easier to update a small Java function from Java 8 to something bigger than the huge monolithic applications. We know with that dependency management with Java 8 or above, with Java 9, there are even breaking changes you need to carefully. If you have monolithic application, it's a huge bunch of work. I think it's not so with the serverless functions. So you can do it function by function, and I think it's quite easier. So there's of course reasoning about that. And yeah, what Dan said, of course, I mean, Java 8 was 2014, something like this. We are now 10 years later, so I think it would make sense to move forward. Sometimes, of course, if you have a huge application, and we also have parts with Java 8, I know how difficult it is for the huge applications, all or nothing update. And this is what needs to be tested, and all these situations.
Yeah, and many new technologies actually impose a number. Native works only from 17 and 21 in terms of long-term support. Spring Boot supports only 17 and 21 exactly because of that. The major change from Spring Boot 2 to 3 were actually two things which triggered a major release. One was support for native. The second one, JE dependencies have been moved from JE to Jakarta. So of course, those are breaking Those are breaking changes. But it's obvious maintaining a plethora of versions becomes very difficult, and keeping up. I mean, I'm sure we're going to see Java 5 probably 10 years from now running in some system, which is still up and running, but updating is recommended. And the scale and the effort could be simply from a function, much simpler, to a larger service, not even say mini micro service. A service are different efforts.
And of course, the same is with the Tomcat. As far as I know, Tomcat 10 or 11, they will also require at least 11 or 17. Of course, you can stay with the older version, which is then not officially supported with all CVEs. It's then another risk, basically. Yeah. So this is not the situation I would like to be personally. And Java 11, Tomcat 11, I think they require different standards of servlets and all that stuff that's also not compatible anymore. So sometimes it's simply time after X years to put an effort to move. And I think if you will jump from Java 8 to Java 9, then it's not very difficult to update to Java 21. On my experience, because there are no breaking changes. There are only a bunch of additional features, so it's basically then easier.
It's like the legacy code is like abandoned child. Like there are no more developers. It just works somewhere in the corner. No knowledge. You don't want to be the one to break it just because you want a new version. So that was a thinking.
There are many because I get involved in. I work a lot around like app modernization, whether somebody wants to build a new app or rewrite one or maybe break up a monolith. I built microservices like 8-10 years ago when they were not popular. The idea is many times it's business decision to drive something. If you have an app which does a batch once a night or once every 2 hours, and it runs reliably on a machine, that's not your first investment. You're going to invest where it brings more benefit to the actual organization. It's a business decision. There are no infinite resources, and also not infinite human resources to migrate that. And even if we would like to do automated migrations, they very much depends. We have to decide what we want to upgrade to. There's no crystal ball. It requires work and prioritization.
I like that. I'm going to use that next time they ask me to upgrade something.
Sometimes, from my experience, of course, a different topic, the external triggers like security incidents and all that stuff. This is what work. Sometimes post-mortem more because it's kind of security is that much important, and having Java 8 and all that Tomcat version or whatever it is, dependency that can be updated anymore, or open source project that is discontinued. There are risks, but it's also then an effort to mitigate them.
And the distributed world, and serverless is part of that. Serverless makes it even easier to distribute workloads. And whether it's in the classical traditional types of application, or we add now new Gen AI features to it, we also have to think that in the past we had two WebLogic servers. One would do one thing, one would do the other, maybe three of them. They had the IP of the load balancer, many times hard-coded. There's one day when you have to change that, and then you have to touch that code. And when you touch that code, that's just the beginning of unraveling, like a thread of yarn, right? And in reality, there are points in time when you can keep it up to a point, but there's a point in time when maybe you would have to change.
Awesome. Any other questions? Like I can stay longer, but it's late in Europe, and I'm going to go through the raffle soon. So any other question, feel free to open your mics. You definitely lit the fire. So we're going to have more Java serverless meetups, I promise. And again, thanks Vadym for bringing this up and then for explaining.
Oh,
It's my
there's a
pleasure.
question from Alexei that people are afraid that they will become obsolete if more ordinary people. Well, there's a difference between, let's think about this. One is you use every tool, like it's not the same hammer for every single nail. Kubernetes is great at a number of things. Serverless addresses the same or many other different use cases. In the end, it's how we run them. Of course, in Kubernetes, you build a platform. It requires more specialized knowledge. The effort of getting a platform is more significant. It gives you more control. So you're balancing operational simplicity maybe versus control. But from the developer perspective, and we want to shift many things left, the important thing is that we containerize our applications. Then how they get run from a developer perspective, nobody becomes obsolete because of that. That is not really going to be the case. How we operate them, that is a different story.
Yeah. No, absolutely. And I understand your view, but from the development perspective, what I often hear, I mean, like if you have a product, like for example, you and the team working on the business product, and you have relatively simple new standard features, and you practically don't, like improve your technical competence, right? And of course, then I want to have at least more freedom to play with some non-functional, like platform engineering or whatever I want to call it, right? Because while I'm creating a new feature for the product, it's like the same stuff. I'm just creating a function, right, on the Cloud Run or whatever. It doesn't bring me much joy as a developer, and potentially also not much of my personal development. Yeah. So that's one point.
It's of course different. People have different interests, different perspectives.
Sure.
I come from the app world. I built frameworks in the past. I built a framework a few years ago with some friends. It runs in production. It was faster than Spring. It's not overall better than Spring because of the large ecosystem. But for a particular set of use cases, blazingly fast.
Sure.
So I like to squeeze a millisecond out or more if I can out of an application. I'm trying to see if the same applies to GenAI. I had a session at DevOps where I talked about bringing GenAI to the modern enterprise. And we're a full-fledged GenAI application started up in 700, 500, 700 milliseconds. So with dependencies, which you cannot avoid because you need them, it has this and this and this and different databases and different LLM configurations. So that is the interest which everybody has. Unfortunately, we can't be. I would like to know a lot more on many other fronts than I know in the one which I focus on. It's so much new information which comes along that we have to realize that it's not the same like 20 years ago. I understood WebLogic inside out, or more than that, and what I could do with Java, but the world has changed so much.
Absolutely. Thanks, Dan.
So that brings a good topic. So when we started Meetup, I mentioned that Dobrin is now helping introduce generative AI features into the Java world. Where can people learn more about your work? What do you want them to read up next? So excite them like you excited me about modernizing Java.
One thing which would be of interest, maybe, is, but you need some patience. I gave this deep dive at DevOps because my argument is this. Gen AI adoption is driven by business needs, not by technological aspects. It's not, of course, we all like to be very curious. We like to try new things, but that does not mean anything. We live in the real world and we want to acquire skills and put them to good use in some applications. So what would drive adoption? People find new ways, or they need to resolve problems in different ways, which they couldn't do before. So they're adding these features. So the DevOps talk I gave addresses things in two parts. One is the architecture, why a system is built. Of course, it's a fictitious university bookstore. My children were very happy that I was thinking about their school. And in the second part, I want to talk about best practices, because things which we learn now in the cloud, they're not obsolete. We should learn, if we externalize variable, we should externalize prompts. We should be careful about things. We should learn about the different choices. So I can share the link. I have it. I find this very interesting. The next thing which I'm really interested in is AI patterns. Technology changes, new models come along, new technologies come along, but we have to learn, like we learned about the gang of four patterns and integration patterns. AI patterns emerge now, and we are just starting to scratch the surface. I explored some in some blogs, but I realized that this is the very beginning.
That's awesome. That's a really good answer. And you know what I'm seeing, because like the new kids are coming with new technologies, they're not aware of what existed before. There are some old ways of thinking in tools. You mentioned Gang of Four that can be applied nowadays, and we just need to educate them. So that can be another good topic for the meetups coming up.
Yeah, some of the things just evolve in a different way. The enterprise integration patterns, I think they're as valid as they were today. Sure, maybe now we have PubSub can move billions of messages a day and so on, but the concepts of what it means to build an event-driven architectures are the same. To use the tool, we need to understand what we want to do with it conceptually. And if the tool does not support what we want to do, then we're in the wrong business.
You are mentioning once again Gregor Hoppe from Germany. You mentioned him in his presentation in his book Enterprise Integration Patterns 20 years ago. And ironically, last week I was in Berlin on serverless architecture conference, and Gregor was there for keynote, and he visited my talk about operations on serverless. And after that, he is now the former AWS employee. He was at
AWS,
but he left AWS in summer, and he gave me his signed book, Platform Strategy, after the talk. And it's, for me, was kind of like the God visited my talk, because we made the photo with that. And I'm kind of excited that the person comes and say, I would like to visit your talk. Amazing person. He has written so many books, Architect, Elevator, Cloud Strategy, now Platform Strategy, which is on LeanPub on early but this is evergreen book. This is like for Java, the patterns with Joshua Bloch. Many of them are incorporated in the language, but this Gang of Fourth and all that stuff, these are amazing things. They will never alter.
Just amazing. I pasted the link for
Gregor. I showed Gregor my slide. I met him at DevOps. He gave a couple of talks, and I said, "Look, I quote you for the longest of time, and I quoted in my talk also the Graal folks who had a session in parallel. It was funny." And he's like, "You're from my generation." I was like, "Oh, thank you." But is this true? I said, "Look, I just talked about it like 2 hours earlier." So.
Oh my, that's so appropriate, because Gregor served Google for me twice, and then he served Amazon. So like two of you representing two clouds, Gregor worked everywhere. And I've been inviting him to these meetups, but he was always in Singapore. I cannot join you. So now he has no excuse if you saw him in Germany. Gregor, if you're watching, you're coming soon.
I think he lives in Asia still, but now I don't know how long, but he is kind of independent, giving workshops on this architecture stuff, visiting. He has the tour in Europe. Visiting DevOps. I think he gave two talks and one deep dive. But he is, of course, kind of
brings back memories. I paid half of the mortgage with his enterprise integration patterns, and those meetups that we used to have, John, at My Planet. Lots of the slides were inspired by his work. So amazing, walking down the memory line. And we are over the time. I'm thanking everybody who's here. If there are no more questions, I can do the survey. So mining publication surveys. you would, whoever wins, you would share your email address with me. Here, I'm going to introduce you to the folks for mining, and you're going to choose any e-product except bundles and learn from there, go from there. No, Gregor's books are not there, but there is lots of good material as well. So let me share the screen. As you were talking, Gregor, that's his site. And then wheels of name. Yeah, there was one more link before we do that. As you were explaining, Dan, about all technologies, like one of our presenters and friends, member of the community, Panka Chupreti, he's blogging about what's old is new. And like I shared the link in here. You don't have to read it up, but you can jump in. A really deep thinker and currently consultant as well. So.
I'm not aware with his work.
He's a local Toronto guy. Like 2 meetups ago, his session was recorded. He started developing astrological horoscopes using serverless technologies and an AI. So I just follow his work. So anybody here, we're back to Raffle. Anybody that does not see his name, William, I don't see you. Maybe I can add your name. No? And then H, just in case if there is more bills. And then I don't know who you are, so I wouldn't be able. Anybody else? No? One? Going twice? 3 times? Okay, spin. Mikkel, are you still with us?
Hey, I am, yes.
Well deserved.
Hey.
You've been with us from since the first meetup.
Thank you.
In 2018.
Thank you, Daniel.
But you have to read
Thanks,
those
Daniel.
books. I don't think it's your first.
Oh, yeah, of course.
So
Of
so
course.
whoever didn't win, these days they have 50% off. So it's quite cheap now to get, when you buy the print product, you get ebook as well. I haven't, like, we're not marketing them. It's just a good, inexpensive place to learn. I know Google has deal with O'Reilly to publish books there, but this is learning on the budget. So that's from me. Any closing thoughts?
Yeah, thanks for the invite once again. I always enjoy the round that we can talk, discuss, share opinions.
Yeah, that was
Even
a
if
lot of
it's
fun.
now midnight in Germany, but I didn't even notice. And it's Monday. It's always kind of one of the most difficult days in the week.
Thank you so much. And sorry we couldn't connect when you were here in Toronto. The idea was to have the talk while we were here, but we already had August scheduled.
I had only one night. I just was traveling for the first time in US, and I came with my sister to Niagara Falls and then to Toronto with one night stay. But we communicated and fixed the date as I was in Toronto. So I have my fresh memories visiting the city, and now I presented kind of for this meetup. So that's
thank you.
Now circling.
To both of you, please.
Thanks for the invite, and it's a great idea. We can exchange ideas. We can all talk. We're all in the same boat. We're all trying to build something. We're all looking to learn something, and there are not enough of these meetings and it would be, of course, much nicer to meet in person.
Not easy to organize.
It gives us the opportunity to keep a dialogue going and learn from everybody else's experience over time or current. And I think that's something to be continued in the future.
Thank you.
Right,
and
thank
I'm
you
looking
both
forward
very much.
for receiving slide deck so I can share them with the community if you're okay with that.
Yeah, of course. I will put it on slide share and then give you the link.
Thank you. Dan as well. It was so hard to scan your these QR codes.
Okay.
Thanks a lot.
If you're okay. Thank you.
Attendees.
Thank you, everyone.
Thank you, everyone. Good night.
Bye.
Thanks, guys. Good night.
Bye.